Hello, welcome to Programming Rainbow. In this video, we will continue on the series of the Beginner's Guide to SDL2 in the Odin language. Okay, so this is going to be video number 8. This is where we're going to add music and sound effects to our project. So if you're just starting out with this one, you want to go to github.com, Programming Rainbow, and Beginner's Guide to SDL2 in Odin. You'll want to git clone this repository, move inside of the directory with whatever editor you're using, and the code that you'll find in the very top level directory is the final code from video number 8. But since we're just starting this video, you'll want to grab the code from video number 7 folder and copy that into the top folder, and that will be where we're starting with in this video right now. So we're starting with where we left off in video number 7, where we created the player sprite. So let's just launch this and see where we left off with. Okay, so we have a window that's 800 by 600. We have a background image, Odin, that's partially transparent, and we can change the background color behind it by pressing the space. We have the Odin true type font text bouncing around the screen. We have a logo loaded that we can move around. And it also has a icon that has been set for the window that we can't see in my window manager, and we have a window title up here. Okay, so we are going to be adding background music and sound effects. So we want to make this every time the Odin bounces off the walls here, the sides, we want it to say Odin, and every time we press the space bar and change the color, we want it to say SDL. Okay, so that's the first thing that we're going to do. So I'm using the SDLC reference guide because it has the most information on it, but you can also go into package.odinlang.org, vendor, SDL2, and mixer. We are adding a new module in this one. It is called mixer. Okay, so the first thing that we want to do, we're going to add the mixer module, and then we are also going to initialize mixer. And this looks very much like the other ones. We have some flags that we're going to put in here, and we're going to get flags out of it. So we're going to be checking those. And the only flags that I'm actually interested is the only thing I want to make sure that's loaded is the OGG, the OGG file type, because that is the only file type of sound that I'm going to be loading for both the sound effects and the music. They're both going to be OGG files. Let's check that out just to make sure. So let's see, can we move this over? Yeah, that's an OGG file. And the sound effects are both OGG files as well. So the only thing we need to load is OGG. Okay, so I'm going to make another flag here. And we know it's, well, the first things first is we need to bring in this. So it is called mixer. So it's going to be just like the other ones, import, and I'm going to call it mix because this one is in C, it would be capital MIX underscore for the name of all of the functions. So I'm just going to use mix. And this is going to be vendor, SDL2, and mixer. Okay. The actual package is in C is called SDL2 mixer. That's the package name, and the prefix is mix underscore. Okay. So that's where we're getting the SDL2 mixer from, and that's why we're calling it mix here. So we saw here the flags, this mix init, and I want the OGG. So this for me is going to be init OGG. So I'll call it mix flags. And this will be mix dot init. And whoops, let's go up one right there. And these can be OR'd together again. So again, I only need OGG files, but if you had MP3 and OGG or something else, you could OR them together to get multiple flags. But I'm using just one, so I'll be doing that. We have our flag set there. We have our package. So when we go down to initialize here, we're initializing SDL, we're initializing image, we're initializing TTF, and now we will initialize the mixer package. Now, it's going to look very much like the way we initialize the image package, where we have these flags coming in, we're capturing flags coming out, and then we're masking them with the bitwise AND operator and then checking against the original flags. This is going to look very much like it. So I'm going to just take this code right here. It's doing the exact same thing. If we look at right here, we have flags coming in, and this int coming out is actually the flags. Int, yeah, this is returning the initialized flags. So flags coming in, flags going out, and then we check it the same way. So I've already kind of explained this on the prior video where we were talking about image loading. So this has already been covered. It's the exact same thing happening. So I'm going to call this mix init for how I'm capturing the output of this in a local variable. And this is the method or function or procedure, however you want to say it. It's in C, it's a function, but here it might be called a procedure. So this is mix init, and then we have the mix flags. Okay, so now we need to mask out. We need to take this. It needs to be here. Okay, and we're going to mask it with the original mix flags. And again, this was explained in the prior video where we loaded the images for the first time, and we go into depth on this. So I'm not going to explain it again because I've already explained it before. I know there is going to be a slight difference in this though, and we'll cover it in a minute here. So we have the captured flags in this local variable, and I'm masking it with the original intended flag, so I get only the answer I want. And now I'm going to check it if it's not equal to those flags. Okay? And if it's not, this is going to be mix error. And we'll say this package is actually called SDL2 mixer in the C library package. That's what it's called. So I'm going to name it that. Now, when I save this, it's probably going to complain up here. Okay, let me do that. Yeah, it's talking about mismatch. Let's get the diagnostics. Mismatch type and binary expression. And the way I went around this was just casting. Since this is an I32 that's coming back out of here, let's look at it in the Odin one. Right here, I'm just looking on the right-hand side. I want init. So we have type coming in is of type init flags. That's the type coming in. Okay, in C it would have just been an I32 or something like that, but it has a type. But what's being returned from it is not an init flags. It should be, but it's not. It's an I32 instead. So I think they've maybe messed this one up or got a little bit lazy with it. So this type should be the same as this type, but it's not. So maybe they couldn't implement it correctly. I'm not really sure. So what I'm going to do is I'm going to take this and cast it to an I32 so it lines up. And it still seems to work fine. So I'm going to take this at least when I'm masking it, I'm just going to cast this to an I32. And that's going to solve that one. But here when I check equality, again, we're going to get the same problem. So I'm going to cast this one to an I32 as well. And again, I'm not an expert in Odin, so I might not be doing this the most optimal way, but this appears to work. Okay, so now we don't have the type problems with that, and the whatever number was coming out of here, it's the same. So it's still going to give me the answer the same way. The mask is still going to work, and then checking it against the number that I wanted is still going to work. So we have this package loaded now, and the way that we unload it is here, and it is mix quit. I feel like we didn't, in the prior video, we should have been closing down the font. I think I've missed it way back. Yeah, TTF quit. So that's quite unfortunate that I missed that step, but TTF I think was the second one in after image, yeah. So we're going to put it in here. So hopefully anybody who watched the video where we load the true type font, we'll watch this video as well and see that we do need to. It's not going to break the program or anything, but it is just good behavior to always clean up after yourself. So ttf.quit, it's the same. Okay, so that should have been there, and this is what's closing down the mixer for us now. Okay, so, but this isn't going to get us everything that we need to get the mixer up and running. We actually need to open an audio. So we've initialized the mixer, but we haven't opened audio. So that's initialize mixer. Now here we have to open audio, and unfortunately there's some parts to this that are just not explained. Let's see here. Default. Yeah, let's check in. It might be listed here, but I don't know if it's explained here. Default. Okay, here, default channels. But it's not explained, so. Yeah, it's. So this is unfortunate. I know that this exists, and it's in the header file. If you actually open up the header file for this, I don't think there's access to it here. Wait, and open. Oh, is it here? Can I? Oh yeah, okay. Here we go. Okay, so we have these defaults, and I really wish it said it on the page. Let me go back and open this up as a separate window. Okay, so if we're here, when we open audio, it's going to ask us for a frequency, it's going to ask us for a format, it's going to ask us for channels, and it's going to ask us for chunk size. And you might not know what you should use. So what I did is just use the defaults that are not even spoken about on this page. I'm not sure why they're not spoken about. They do exist here. Like we see the default channel and the default format and the default frequency. These are here, but they're not explained here. This is literally just telling you what it is, but not why it is or why you should use it or how you use it. It's just there. And this page that we would need to use them, we could put the default frequency here, the default format, and the default channels here, and there is no default for chunk size, which is unfortunate. But it's not explained anywhere, but it's actually inside the header file. Inside the header file, they're defined here. So we could use these numbers, or we could just use this mix default frequency, mix default format, mix default channel, and that takes care of the frequency we should use, the format, and you could use your own. I think it's using 44,100, and you could use 48,000. The format, this one gets more complicated, and I don't believe I can explain it properly about how this format works. It's different styles of 32-bit or 16-bit, and so on and so forth. That's the format. And then the channels is talking about, is it mono channel, is it stereo, or do you have like 5.1, so on and so forth. So I'm going to use the default for all three of these. The chunk size is, let me just read it so I don't explain it correctly. The audio device chunk size is the number of sample frames, one sample frame for mono output and two sample frames in a stereo setup that are fed into the device at once. The lower the number, the lower the latency, but you risk dropouts if you get too low. So 2048 is, it says a reasonable default. For me, I can hear the delay in 2048. If I paid attention, maybe I could hear it in 1000. I can't really if I'm not paying attention. So 1000 is just fine. But what happens is if you make this number too small, you get the crackling sound. Because you're getting dropouts, you're getting a loss of information, and when you get that loss, you get these crackling sounds. So if you've ever heard an audio device that crackles, that's probably, it could be many things, but it may be this. So I've been using 1024 here, and it seems to be fine. So there is no default set, but it says a safe one is 2048. I've been using 1024. And yeah. So we need to open this audio, sorry, that's audio device. I'm just going to use open audio. This one right here. This is going to open an audio for us, and we're going to close it as well. So this is setting it up, how our sound is going to work. So I'm going to use this, and like I said, I'm going to use these defaults, and then I'm going to use 1024 right here for the, so it's going to be 44,100. I forget what the default is here. It is audio S16 sys. So it's assigned 16-bit, I believe. Yeah, I don't really understand everything about that. And I'm going to use 2-channel, which is stereo. Okay, so you can read more about this, but I just want to know where I want you to know where I'm getting these defaults from. They do exist. They're just not spoken about. So this is going to be mix open audio. And right away, I'm going to use mix. And I believe the first one was here. Let's do it again. It is frequency, then channels, then, or sorry, frequency, format, and channels. Okay. So it's going to be mix default frequency. And then mix default. And it's nice that the LSP is helping me out. The next one is format. And then mix default and channels. And the last one, we're just putting a number, so I'm going to put 1024 in. Yeah, we could do that up here. We could add a we could add one up here for chunk size, and we'll put 1000. So you can easily change it if you find that it's not what you want. Okay, so chunk size there, so I'm just going to use that instead of the magic number here. Okay, and let's see if we can. So this is, I believe, returning 0 on success and -1 on failure. Let's check. Okay, 0 success, -1 with an error. That's kind of the normal. Anything that's not a pointer, it's probably something like that. So we could put this in an if statement. And I'm wondering if I could break this up. Let's see if the LSP breaks it up for us. I'm going to say if it's not equal to 0, then something's gone wrong. Okay, and we can just take one of these. I'm just going to yank this. And it's still a mix error, and it's going to be opening audio. Okay, let's see if we get some formatting. Okay, there we go. I thought I'll do all this stuff and move it around, and I thought the formatter is going to move it for me anyway, so I'll just let it do that. So we have initialized the mixer, and we've opened an audio. Since we've opened an audio, there is another one behind it that closes it. Where is it? Here it is, mix close audio. It does what it says on the tin, and there's nothing going into it, and there's nothing coming out of it. So I'm going to put this up here in the game cleanup, and I'm going to put it above all these module shutdowns. So mix, close audio, and I'm just going to separate it out. So okay, so that should load. That should start up the module, open an audio, and then on the shutdown, it'll close the audio and unload the module. I just want to compile this, even though we're not going to notice anything happen. I just want to see that I don't get any errors. Okay, I think that's working fine. Okay, so now that we have this up and running, let's load some audio files. I'm going to close some of these down just to make some room. Mix, open audio, the header file. So we have two different types of audio files here. We have sound effects that are chunks. And I know it's chunk, and we just talked about chunks, but it's a different chunk. The 1024 is not the chunk I'm talking about. So sound effects are called chunks, and it's of type chunk. Right here, mixed chunk. And then there is also mixed music. Let's see if I have that. And this is load mixed muse, and it's of type mixed music. So mixed chunk is for sound effects, for short sounds that can play on top of each other. And by default, we have 8 channels that we can play 8 sound effects simultaneously before one has to finish before we can play another one. And then for music, we just play one music file and it can play continuously. So we can play one music and then we can play 8 sound effects. So if we go past 8, the new ones won't play. They'll just be ignored. And there's actually an error that comes off them that I'm going to ignore. But when one of those 8 has finished, then there will be a spot open for another one to play. So there's 2 different types, and we're going to start with the chunk first, which is the sound effect. And it's called load wave. Even though we're not actually loading a wave, we're loading an OGG. That just happens to be what the function's called. So we're going to load our OGG file with a function called load wave, and it's going to return a mixed chunk. Okay? And it's just taking in a string to where this file is. So very simple. So in load media, right down here, I'm just going to add something here. And this is going to be just like we loaded anything else. We're going to get a pointer back. So I'm going to make sure that I add it here. But we have 2 sound effects that we're loading. So let's just look at the names real quick. So we have Odin and SDL. So we'll call it Odin sound, maybe. Odin sound. And that will be of type pointer to mix chunk. Now, I can't remember if it's mixed chunk or SDL chunk. I think it's actually SDL chunk. It is mixed chunk. Okay, fair enough. And the next one will be the SDL sound. I'm just putting a more descriptive name. I don't want to just put Odin and SDL. It's not descriptive enough for you to just at a glance know what's going on. And this one will be also mixed chunk. Okay, so that gives us our 2 pointers to chunks. So down in load media, we could say Odin sound equals, and it's going to be mix load wave, and it's capital WAV. And all we need here is the the relative path to the file. So the relative path is going to be sounds, and then OGG. I'm not sure why this is in here. I've made some error here. This folder should not be inside of here. But sounds, and then we're loading Odin.ogg. Okay, so we want to check to make sure that this has been loaded, and we're going to do it the same way that we're checking everything by seeing if the pointer is still nil. And I've messed up here. This is g.odin sound. So if Odin sound is nil, error loading chunk. And this error is coming from mix. Okay, so that should be correct. Let's save it and see if the linter complains. It looks good. I'm going to yank this right here and put it right down here because it's going to be very much the same for the SDL sound. So we just need to change the Odin to SDL. SDL right there and down here. Okay. So now that we've loaded them, we also need to unload them. And the way that we unload them is with free chunk. And before we unload them, I actually want to make sure the chunk sounds are not actively playing. So I'm going to use this mix halt channel, and I'm going to put a -1 in here. We can put, basically we can choose what channel we want to halt, but if we put a -1 in here, it's going to halt all channels. So what I'm going to do is I'm going to halt all channels first, and then I'm going to unload the resource. And you don't have to do this, but I feel like it's a cleaner approach. I'm taking the more cautious, more deliberate path here. So I'm going to use this halt channel right here. And in the cleanup, game cleanup, before I start unloading the chunks, I'm going to run that. And this is a mix dot, and we will just put the -1 in here. Okay, so now that we've done that, we want to run the other one, which is that's halting, and this is the mix free chunk. This is, again, very simple. It just takes the pointer to the chunk and it frees it, and it doesn't return anything. So it's just like these other ones. So I'm going to do the same thing. I'm going to make sure the pointer is valid, and then I'm going to free it. So it's Odin sound, and we'll make sure it's not nil. And it's going to be mix free. So we have a free chunk and a free music. For this one, it's the chunk, and it's going to be Odin sound. And I'm just going to yank this right here because the other one's going to be very much similar to it. So we have SDL, and over here. So we're halting the channels, we're freeing the chunks, and then we're closing the audio down here, and we're quitting the mix. So there's quite a few shutdown steps here with the audio, okay? So we have the audio system up and running, we've loaded some chunks, we're shutting them down, so let's use them. Loaded wave, we freed a chunk. We've already closed audio, I believe. Should have done. Close the audio, we've already done that, so I'm going to close this. And the way that we play the sound effects is by playing channel, and we can choose a channel we want to play on and keep track of what channels are on, but we can just tell it to pick a channel for us, whatever channel is available. And when I say channel, I don't mean right channel and left channel. I mean there's like, I believe there's 8 channels, and they're not right and left. They're just like spots that sound effects can be played. So the channel on which to play a chunk. It also asks if you want to loop the sound, and we don't want to loop the sound effects. So the number of times the chunk to loop, -1 will loop indefinitely. So if we wanted to loop, let's say we want the sound effect to play 1 time, we're going to put 0 for the loops. If we wanted to play 2 times, that's 1 loop, that it plays 1 time, and then we put a 1 in there and the loop happens 1 time. So I don't want it to loop at all, so I'm going to put 0 for the loops. But the channel here is what I'm interested in. I believe we can put a -1 for the channel. If the specified channel is -1, play on the first free channel, okay? So that's going to basically say whatever channel's free, play on that channel. And when we run out of channels, it's actually going to return an error. Right here, the returns which channel was used to play sound. So it's going to return a channel to us, but if it's -1, it means the sound didn't get played. I don't care, actually. If it didn't get played, it'll, if I press spacebar too many times and it plays the sound effect too many times and it can't put any more at the same time, it's just not going to play that time that I press it, and that's fine. I'm not going to worry about any sound effects not playing because they were stacked up too high. Okay, so play channel, and we're looking at -1. We have our chunk that we want to play, and the loops are going to be 0. So where I want to play it, let's look at Odin. The Odin sound effect, I want it to say play when the Odin font bounces or text bounces off the walls. So every time it changes direction, I want it to play the Odin sound. So text update right here. So we can say mix play channel, and it's going to be the channel we want. So we're going to put -1 first available. The actual chunk we want to play is going to be G Odin sound, and then how many times we want it to loop, and I'm going to say 0. Okay, now this is only if it's bouncing off the left wall, so I'm going to make it play for all of the walls. And the other time I want it to play is when I press the space and it does the random background color. I want it to play then. So I can just put it right under here. And I don't want it to play the Odin sound. I want it to play the SDL sound. Okay, so we should have sound working. Let's see what happens. Okay, Odin's bouncing off the wall.
Noted, obviously. Noted, obviously. Noted, obviously. Noted, obviously.
Okay, and I'm going to start pressing the space bar.
SDL.
Noted, obviously. Noted, obviously.
SDL.
Noted, obviously.
Okay, that all seems to be working as expected. So that is how to play sound effects. And again, if you try to play too many at once, it's just not going to play the new ones until there is space open again. So no, I'm not checking for any errors. I'm just saying try to play the sound if you can. Okay, so now we have the music. So this is the mixed channel. That's all that done. Now we load music the same way we loaded a chunk, except the function is load muse. We're saving it in a file type of mix music. So we can set that up pretty easily. I'm just going to go to the game struct again, and I'm just going to call this one music, since there's only one music file ever, so, or at least that I'm using. I'm just going to call it music, and it's of type pointer to mix.music. Okay, and the loading of it is going to be very similar to the chunk, so I'm just going to duplicate one of those. Except this time we're grabbing it in music. And this is going to be load instead of wave, it's MUS capitalized. And the file is the 8-bit version of the free software song. So it's in music. And let's look at this was written by Richard Stallman. This is the 8-bit version of it. Come on, is it going to let me? There we go. So this is free software song, and it's the 8-bit version. I think it's Moo Gnu or somebody who made this version, this 8-bit version. It's pretty funny. I just put it in a loop. Okay, so this is free soft song and 8-bit. And this is an OGG file. And we're going to do the same thing where we're checking to see if the pointer is valid. And we'll say error loading music. So to unload this, the very first thing we want to do is stop any music from playing. So it's halt music, stops the music from playing, and then we free music. That's the way that we free it, just like free chunk. So if we go up here to the cleanup, right up here, I'm going to say mix halt music, and there's nothing is passed into that. And I'm going to just put this with the other audio files right here. And this one's music. And the function is free music. So we're halting the music that's playing, and then we're freeing it. And then the same thing happens with the close audio and the mix shutdown. So that gets us up and running, but the way that we play music is a little different. So I'm going to close the load music, the halt music, the free music. So we play the music with mix play music, and we just need to put in the name of the pointer to the music and then the loops. And for here, I want it to loop indefinitely. So I believe it's, even though it doesn't say here, I think it's -1. The number of loops play. Let's see, maybe it says somewhere. So it's not listed on this page, but -1 will make it play indefinitely, like the mixed chunks did. So even though it's not listed here, returns 0 on successor. So we're going to check this one. Since it's playing the music, we're actually going to check the output of this. 0 means it's good, and -1 means it failed. So I'm going to make this play in the load media section right below where I loaded it. I'm going to have it play there, and then I'm going to check to make sure it's played. So I'm copying this, and in the load media, right after I load it, I don't like how this is long right here, but okay. Right after I load it here, I'm going to say if, I know I'm checking for 0, so and it's going to be mix.play music. And we're looking for the pointer to the music and how many loops we want. So it's going to be G music and -1. And what I'm checking is if this is not equal to 0. If it's not equal to 0, something went wrong. And then I'm just going to grab one of these error messages here. And we'll say error playing music. And we're getting the mix error from that. That's correct. So this is going to make the music play, but I do want to be able to pause the music. So let's just make sure that this is working first, that I haven't made any mistakes here.
Noted, obviously. Noted.
Okay. The audio is delayed for me, so I had to wait a little bit, but it looks like it's running perfectly. Okay, so the way that I want to pause it and resume it, but I want to toggle it. So what I'm going to do is I'm going to see if it is paused. If it is paused, I'm going to resume it, and if it's not paused, I'm going to pause it. So I can check to see if the music's paused, but with this paused music, and this is returns 1 if music is paused and 0 otherwise. Okay, so I can check this one, and I'm not sure if it's returning a bool in Odin. Let's check if it's a bool. Paused music. It's returning an I32. Okay, so we have to check the number manually. And the other two is to resume the music, and it doesn't even have an error check, or to pause the music. And it doesn't take a pointer to the music or anything because the music, there's only one music. So when we play the music, we're not stopping the music, we're just pausing it. The pause and resume is saying, hey, the SDL already understands that there's a music file, and this is just pausing and unpausing it. Okay, so this is basically a toggle. And we'll set this, let's see, I'll make another. So right above game run, let's make a new procedure called toggle music proc, and we need to pass in G. Oh, no, we don't need to pass anything into this one, I think. So we're going to say if mix paused music. So there's a paused music and a paused music. So I'm checking paused. I want to know, is the state of it paused? And if it equals 1, it is paused. So if it is paused, we want to resume it. Mix resume music. And then else, we want mix pause. So if it's not paused, we want to pause it. And this is just our toggle. And make sure there's no D there. The D is when we're checking. And this is not right here. This should be like that. Okay, so this is set up as a procedure, but we're going to put it on a key, and I'm going to put it on the M key for mute music, even though it's really pausing the music. I just put it on the M key. Case.m. And we'll just call this procedure. Don't know why it didn't indent for me. That's weird. Toggle. Okay, so let's see if that works.
Noted, obviously. Noted, obviously. Noted, obviously. Noted, obviously.
Okay, I'm going to pause and unpause.
Noted, obviously. Noted, obviously. Noted, obviously. Noted, obviously. Noted, obviously. Noted,
okay, that's Odin, obviously. So that seems to be working. So we have our toggle set up right here, and we're just checking if it's paused. If it is, we're resuming. Otherwise, we're pausing it. It's pretty straightforward. I think that is everything. So let's just cover what we've done here. We've imported mix from vendor SDL2/mixer. And we have some mix flags here. We're using mix init og because we're making sure our mixer has og files initialized. And the chunk size that we're using for the open audio is 1024, so it's just set up here in a constant. We do have some new members of our struct. We have Odin sound, which is a mixed chunk, SDL sound, which is a mixed chunk, and music, which is a mixed music. Let's just go to the initialize. So in initialize, right here, we're sort of doing the same thing we did with the image, where we're passing flags in, we're capturing what came out of it, which are flags, and then we're trying to mask it and check it. But we do need to cast it to I32s for it to work with that checking. And then we need to open an audio device. And we have a frequency, and we're just using the default. We have a format, we're using the default. We have the channel stereo or mono or 5.1 or so on and so forth. We're using the default. And then we're using the chunk size that I set in a constant up above. And if this doesn't return 0, something went wrong. Okay, I'm going to remove this extra here. So that gets the audio up and running. In loading of the audio, we have mix load wave, and this is going to allow us to load OGG files, and it returns the pointer. It populates this Odin sound pointer, which is a mix chunk, a pointer to a mix chunk. And then we're checking to make sure it's not nil. And then if it is, there's an error occurred. And we're doing the same thing again for the SDL sound. And we're doing something very similar to mix music. It's not the exact same thing. It's load muse instead of load wave. And we're in the music folder instead of the sounds folder. But understand that these are considered chunks. And this is considered music. And for the music, we're using play music to play the music, and we're put the loops on -1 so it loops indefinitely. So when the song ends, it plays again from the start. Okay, so and for cleaning up this stuff, we are halting all channels, so we're passing -1 into it. That stops all sound effects. We're halting the music, that stops the music, and then we're unloading the music, we're unloading the Odin sound and the SDL sound, and we're doing that through free music and free chunk. So that's the correct way to free those heap allocated memory. And then we're shutting down the audio with close audio and shutting down the whole mix module with mix quit. So we're playing the sound effects, and we've done that here with mix play channel. We use -1, so it picks the first available channel. We are choosing the sound of the pointer to the mix chunk that we want to play, the sound, and we don't want any loops, so it's just going to play one time. And we're also using it down here in the text update. Same thing. So we're using a different sound effect, but the same thing's happening. And I believe it's 8 sounds that you can play simultaneously. Okay, and 1 music can be playing. And the pause, this is straightforward. This is just returning 1 if the music is paused, and we're just resuming or we're pausing. And we've already seen this before on another case for a letter key press. And I think that's going to be everything. So let me save that. Sorry, what am I doing here? I'm concerned that I just changed something. Let's change that up here. This should be 8. This should be sound effects and music. Okay. And the very last thing we did was play the music, so that should be still there. There it is. Okay. So let's look at it one more time. And we can change the sound, we can move it around. And we can pause the music.
Noted, obviously. Noted, obviously. Noted, obviously.
Okay, so that should be everything that you need to be able to build your own game, at least a simple game. You know how to move things around, you know how to get events, you know how to check key states if they're down, you know how to load images or load true type font and turn that into text and to display it. You know how to manipulate rectangles to move them around. You can get random numbers. And that should be everything that you need to be able to make simple games. I know it's just a demo project, but I kind of wanted to show all the different combinations, the basic things that you would just need to get yourself up and running with a game. So I hope if anybody has made a game with this, that they share it back to me and show me the project that they made, and maybe I can show it off on the channel or something like that. It would be interesting to see anybody using these to make, using this information to help themselves make their own games. Okay, so that's going to be it for this one. I hope you enjoyed it or it was entertaining, and I hope you have a good day. Bye.